Lesson 7 is on calculating probabilities of compound events. So these compound events, remember, come from tree diagrams. So we're going to take our tree diagrams to the next step, like add one more event in there and then figure out some probabilities, calculating probabilities. So it's in a previous lesson, the last one introduced us to tree diagrams as an effective method of displaying the possible outcomes of certain multi-stage chance experiments. The power of tree diagrams, and I know they can get big, okay, and you got to be very careful to be organized with them, but the power of tree diagrams comes in the fact is that we can see what the outcomes are. So if we look at this previous example here, where a family decides to play a game each night, they're going to use a tetrahedral, four-sided die, where each of the sides is equally likely, all four sides. Anyway, randomly determine if the game is a board game or a card game. Okay, so this is the tree diagram we came up with. On Monday, we could do a board game or a card game. Well, if you got a board game on Monday, on Tuesday, you could either get a board game or a card game. But if you get a card game on Monday, you could still either get a board game or a card game. And so we can see board game, board game, board game, card game, card game, board game, card game, card game. We can see all the different outcomes that could happen, okay? So it says, how can we change a diagram if we are interested in mapping possible outcomes overall over 3 consecutive nights? So what if we add that third night? Okay, so we have Monday right here, right? On Monday, I'm gonna put it way up here. Okay, on Monday, we could actually, so if it's in, I'm just gonna say abbreviate it, right? On Monday, the family could either play a board game or a card game. Okay, but on Tuesday, okay, they could also play a board game or card game. So what could happen? They played a board game on Monday, either a board game or a card game on Tuesday. They start with a card game on Monday, they could play either a board game or a card game. All right, so now we're going to add on to that Wednesday. All right, so go from each one of these branches and add your next level, right? So let's say this branch right here. On Wednesday, if we played a board game, on Wednesday, what could we play? Well, we could play either a board game or a card game, right? Doesn't change, but we have to go off of each branch. And it's like one of those things that seems easy when you're watching someone, but it's a little more difficult when you go to do it because a lot of times we want to jump right to the outcome. Let the outcome happen, okay? So if you go to each branch and list your outcomes off of it. Go to each branch and list your outcomes off of it. Go to each branch and list your outcomes off of it. I should say your choices, maybe not outcomes is the best word, maybe your choices, right? So on Monday, if we played a board game, on Tuesday, we could play a board game, or we could play another board game, or we could play a board game, and a card game. So this is where we can see all of our different outcomes. This is the power of a tree diagram, right? You just follow this. Board game, board game, board game. B, B, B. Board game, card game. B, B, C. Board game, card game, board game. B, C, B. Board game, card game, B, C, C. And then we just keep going. C, B, B. C, B, C. So each branch, at the end of each branch, so I should have 1, 2, 3, 4, 5, 6, 7, 8. Should have an outcome. So C, B, C. C, C, B. C, C, C. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 different outcomes. Did I count that right? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So it says if BBB represents 3 straight nights of board games, what does CBB represent? Well, it would represent on Monday a card game. That's the first C here. Then we have a B. So on Tuesday, it's a board game. Board game, not Borg, whatever I was writing there, sorry. And then on Wednesday, another board game. All right, so it says list all the outcomes where exactly 2 board games were played over 3 days. So exactly 2, not at least 2, not more than 2, exactly 2. So if I look, 1, 2, 3 times board games are played. Remember? We're looking for the B. Here, though, we have a board game, and a card game. Board game, card game, board game. There's that one has exactly 2. This one only 1. But this one has 2. That one doesn't. No, and no. So we have B, B, C, B, C, B, and C, B, B. There are 3 outcomes. Okay, so 3 outcomes where there's exactly 2 board games. The cool thing with the tree diagram is we can see the outcomes. We can see them, and we know when there was exactly 2 board games played, or what are the outcomes how many outcomes there are. Since there are 8 possible outcomes representing 3 nights, that's what we got. Are the 8 outcomes representing the 3 nights equally likely? No. Because remember, all right, and this is something you have to think back to the last notes, but remember, they were using that 4-sided die, right? And this is going to come into play in the next example that we'll do in the next video. But they used a tetrahedral, 4-sided die to decide. Okay. So we're going to go over that in the next video because we're going to use that. But remember, a board game was if they rolled a 2, 3, or 4. A card game is if they rolled a 1. So if you think about it, if it's a 4-sided die, there's 3/4 of a chance they're going to play a board game, and only 1/4 that they're going to play a card game.